So a chemistry professor from, I can't remember which one of the University of California universities got in touch to say, look, I agree with you, but you can't say this stuff in public because it will mean that people start to distrust science. And I thought, what better reason to distrust science would there be than finding out that scientists are deliberately, holding back the truth? That's exactly the opposite of what we want.
Exactly. Dr. Stuart Richie is a lecturer at the Institute of Psychiatry, Psychology and Neuroscience at King's College, London. He's the winner of the Rising Star Award from the Association of Psychological Science, and he's written for a variety of journals, including The Times, The Spectator, The Washington Post, Wired, Literary Review, and others too. And he's appeared on the BBC, Radio 4 programmes, including The Infinite Monkey Cage, More or Less, and Bringing Up Britain. More recently, he has produced an important book here called Science Fictions, and it's subtitled here, Exposing Fraud and Bias and Negligence and Hype in Science. It says on the book, as Adam Rutherford said, a desperately important book. Science Fictions brilliantly exposes the fragility of the science in which our lives, livelihood, and our whole society depends. And in an era of fake news and misinformation, Stuart Richie exposes how science itself is vulnerable to abuse, manipulation, and outright fraud. Required reading for everyone. So, Stuart Richie, thank you very much for appearing on this podcast with me today. Thank you.
A pleasure. Thanks for the invitation.
Can we start off with science itself, Stuart? Just briefly describe for us, how does science actually work?
Well, this is an interesting question because it's I think, not what people get to see generally when they see science in the news or in books or wherever else people kind of get their science. I think they don't quite see the peer review process, the scientific journal process. And I actually think even students of science, I often chat to, my MSc students, certainly undergraduates, they're not really sure of the process where all this, information is getting to them, where it originates. So I think knowing about the scientific journal system is almost half the battle in understanding where things can go wrong. Because once you understand what scientists are doing when they're submitting an article to a journal and getting it peer reviewed and so on, I think you start to see where the flaws might creep into the system. So the standard story is that we write a paper, you do an experiment and write a paper, and of course before that you have to have secured funding for the study that you're doing, which is a whole world in and of itself, and what a lot of scientists spend an awful lot of time worrying about. But once you have the paper, you send it off to peer review, and often the peer reviews will be positive, and the editor of the journal will say, "Oh, these reviews look good enough that we can send this off for give it our stamp of approval and publish it in our journal." But often they're not. Often the reviews are not positive, or they're extremely nasty. And I've got some quotes of some amusing, nasty ones in the book. The journal will then reject the article. And then I don't think people realize this, but what scientists simply do in that case is send it to another journal. There are thousands and thousands of journals out there. And I have, been in this situation many times. Everyone I know who publishes scientific papers has been in this situation multiple times, where they get rejected from the first journal that they send to, and then you just go down the list of other journals and eventually find one that will publish your research. And there's no requirement to have taken on board the criticisms that were made of your article when you first submit it to that first journal. You can just submit the same thing and eventually find that you're lucky. And so already you can see a problem there, which is, if one journal doesn't publish it, you can often just find someone else to publish it, even if the reviewers on that first journal found that it was very low quality. Yes, but it's not quite as simple as that, is it? Because you have a range of journals. Each journal has a kind of a pecking order, doesn't it? Yes.
So very often, if you want to publish in the best possible journal, you might want to publish in Nature or Science or something like that. It's going to be very, very hard to get in. And if it's not accepted by Nature, you may well send it somewhere else, but it doesn't necessarily mean that the quality of your paper is unscientific or it contains misleading information. It just means maybe it wasn't quite good enough to get into that particular one.
Or it wasn't flashy enough and exciting enough to get into it, which is a whole other question, which I'm sure we'll get to, on the question of publication bias and the biases of journals. They're looking for certain things, and it isn't always just the quality of the article that
Tell us about publication bias. What actually is publication bias, and how does it influence what gets published?
Well, the definition is that, you know, the tendency of journals to publish research that's, for instance, skewed towards positive results. Now, that doesn't necessarily mean that it's just the journal's fault. So I think journals will tend, on average, to want to publish positive results more commonly. But I think also scientists internalize this, and so they don't even submit negative results, null results to journals, because they sort of learn that, oh well, there's no point in sending that to a journal because no one will be interested in it. And I think there's a kind of very human tendency to want the study you're doing to produce positive results. Maybe you're doing a drug trial, and it would be much better for the world if this drug you were trying for, say, Alzheimer's or whatever it is. I'm thinking of the new Alzheimer's drug that was announced the day before yesterday, which I don't think the data have been released for yet. But you know, it's much better for the world if it's positive, and so you can see why we look more kindly on positive results. But the big problem with publication bias is it distorts our understanding of reality, because if all we see is positive results, then we don't get a good representation of what actually was in the scientific literature, which is often lots of null results mixed in with the positive ones. And so you end up getting to a place where, you know, in one estimation, somewhere above 90% of psychology papers report a positive result for their sort of main hypothesis, which is clearly, you know, unless psychologists are all asking very, very basic questions, or maybe they can actually predict the future using their, you know, psychic powers or something. That's not a realistic proportion of positive results. You wouldn't expect it to be 50-50 perhaps, because, you know, a hypothesis is an educated guess and you kind of maybe expect things to go in one direction, but you wouldn't expect it to be over 90%. I think 94% was one number that I cite in the book. So, you know, there's something very seriously wrong with that, and I think a huge amount of that is because of publication bias.
You go into some detail about that in one of your chapters in the book, and you point out that, for example, maybe half the papers have got positive results, half the papers submitted have got negative results, and yet there's a weeding out automatically of all the ones which are negative because they're not very fashionable to publish, and besides which, if they're backed by pharmaceutical companies maybe who want to sell a drug off the back of them, then maybe they're not going to be publishing those ones. So they will draw a whole pile of papers, and then you'll end up with a much larger selection of positive papers. But you have a very nice way of showing it in a diagram, which explains how after that it doesn't end with that, because there's then other factors which come into play, which start to improve, shall we say, in inverted commas, the quality of the papers. You mentioned something called p-hacking, I think is another thing which comes along next. Can you explain how that works and what that's about?
Yeah. Well, the definition of a positive or a negative result that I'm using is based on the kind of null hypothesis significance test, which is that you're testing whether something is statistically significant or not, whether it is evidence against the null hypothesis or not. And scientists are very, very big on making this distinction. They're very excited when they see significant results and very disappointed when they see non-significant results for the reasons we've talked about. And so what they can do, instead of just not publishing null results, because of course publication, as you've alluded to, can be a big deal for scientists. You know, getting your paper into a big journal, a fashionable or glamorous journal, can be a major thing for your career. Getting papers published, you know, you got to get that CV as long as you can, so you can be much more likely to be given better jobs, promoted, given tenure if you're in the US system, getting grants and so on. So it's all good if you publish more papers. So that's why, you know, the incentive towards publication bias can actually kind of go in the opposite direction, which is we need to publish this. So is there anything we can do to make it look a bit more positive? And This doesn't necessarily have to be conscious. If it was conscious, it would likely be considered to be fraud if you consciously manipulate the results in order to make them look different. But I think some people do run their statistical analyses in such a way that makes it more likely that they will get a positive result, or what looks like a positive result, because actually it makes it more likely that it's a false positive result, that it's a kind of a result that's unique to that specific data set they're using, and not something which would tend to replicate if someone else came along in an independent data set and tried to do the same experiment again. And so that's where this p-hacking thing comes in that you mentioned, which is that you can do all sorts of things with your data set that will change that p-value, which is the test that we use to determine statistical significance, change that p-value and try and get it a little bit lower. So you might drop participants out of your study and then run the, maybe you can make yourself an excuse. Oh, that person was not paying attention, or that person, maybe they're different in some way, so we'll drop them out. And then run the statistics again. And if the p-value gets below the threshold that we consider to be statistically significant, then you'll just stop there. Perhaps you'll add more subjects to your experiment. If it wasn't significant originally, you'll collect a few more data points and then see if it's significant. Maybe it isn't. Collect a few more, and then it is, and then you stop. The problem is that every time you run a statistical test, you run the risk of it being a false positive. The more times you calculate that p-value, the higher a chance that you'll get just a fluke statistical fluctuation that gives you a positive result. There are ways to statistically control for that, but a better thing to do under normal circumstances is to plan your analysis out right from the very start and not give yourself the opportunity to muck around with it, basically, to take people out, add people in, all the kind of things that people do. There's many different varieties, flavors of statistical tests that you can do. And in many cases, it's clear that people have tried several of them and then just published the one that that gets them the best result. So that's p-hacking. And that's what can happen even, to papers which, would have originally had a null result, but it can have it transformed into a positive result by the time it gets to publication.
Okay. And what about the idea of switching your outcome? You're looking for something and then you find you don't get much on that, but there may be a number of outcomes that you've got and maybe you didn't think they were significant, and suddenly you see some outlier somewhere. Can you explain something about that as well?
Yeah, well, for a time, this was very common, even in clinical trials. And we think of clinical trials as being very well regulated. They're since 2000, I think, or thereabouts, they've been required to be registered online. So whenever you do a clinical trial, you have to register on a government website, so everyone can see all the trials that are currently happening and check whether they eventually get published. So actually, we have quite a good idea about publication bias because of these registries, because you can see, wait a minute, 50 studies were done, but only 25 have been published, say. So that's one reason. But also from that, you can see what the intended outcome of the study was. So if it's an antidepressant trial, maybe it's the Beck Depression Inventory, which is the standard questionnaire that one uses to measure levels of depression. But in many cases, you can see this happening from the registry to the actual publication of the study. You can see that maybe they don't use the Beck Depression Inventory. Maybe they use a different depression. Maybe they use the Hospital Anxiety and Depression Scale or some other questionnaire. And the reason that they often do that is because, possibly for statistical fluctuation reasons, they didn't get a positive result on the Beck Depression Inventory, but they did on the other scale. And this happens not just for depression questionnaires, but on all sorts of different measures, different ways of measuring biological samples, for instance, or even changing the whole outcome of a study, not focusing on just depression or just some other outcome. And so that happens in medical trials, but it also happens clearly in trials in studies of many other different types as well. When plans to do something don't get quite the result that you want, and then you just shift it onto something else. And then the scary and quite insidious thing is, you can convince yourself that that was the thing you were looking at all along, or indeed, well, that's more important than the thing I was looking at all along anyway, so I'll just publish this. And of course, it would be better for everyone concerned if you published the thing that you were originally planning to analyze. So you say, look, we didn't get a result on that. And then feel free to do other analyses after that, but you just have to declare that they were done after you'd seen the original result. Or, I'm being 100% transparent here. I did this analysis and then I did some others. And then people can judge that based on, okay, well, this person's actually run 5 hypothesis tests when, they originally had planned for 1. So we might be a little bit more skeptical about the result in this case.
I think that, the more tests like that, or the different ways that you can look at your data, if you can analyze it in 10 different ways and come out with 10 different results, you're more likely to find at least one of those outlying in the direction that you're looking for, wouldn't you?
Yeah. And not just that, another reason that we have a lot of these problems is that there simply are so many measures and people can't agree on what the measure is. So we have this problem majorly in psychology. And just to go back to the example of depression, people can't decide how to measure depression, or if there is a thing called depression that causes all these outcomes, or these symptoms, or if there's some other symptom, if there's some relation between the symptoms, and there's not necessarily this one thing called depression that gives you all the symptoms. And so the fact that there are so many different questionnaires and measures and so on is yet another reason why we have trouble relying on the results of any individual study, because another study comes along and it might use some other completely different measure to do it. So the kind of lack of standardization is yet another issue that we have, and I don't think that's just a problem in psychology. I think that measurement issue happens in many different fields. Yeah.
So with this kind of massaging of figures or papers, or the outcome of papers, how common would you say that is? Is that a very rare instance? Does this only happen to fewer than 1% of papers, do you think? Or is it more than that?
Yeah, well, if you do surveys, and I cite surveys in the book of psychologists, and there are others from economists and from biomedical statisticians, who say that in some cases, so it depends on what the specific thing is, whether it's, dropping participants out of the study, or reporting only the tests that you do that are positive and not the ones that are negative. Depending on the specific thing, it varies from, 15, 20, over 50% of statisticians have done one of these, what are often called questionable research practices. So that includes things like p-hacking and switching the outcome and the stuff we've talked about so far. So it depends. I can't remember the exact numbers for each thing, but these are very, very common. And in fact, I think a big reason for that is that people don't realize what a big effect they can have on distorting the literature. I think people think that these are perfectly normal things to do, or it's okay, or even somehow noble to push one's results in the direction of getting a positive result. When in fact the data didn't show that, and I see this all the time. My personal experience is when you go to talks, people write in such a way, talk and also write in such a way that makes it seem like they're always pushing towards a positive result. So this is the next, the next thing on that diagram that you mentioned, which is, it goes from, publication bias to outcome switching. And then there's spin later on, which is that you get a negative result and you sort of spin it as if it was positive. You write, oh, well, this is trending in the right direction, or it's very, very nearly significant, or, all these kind of things where people betray, I think, their own lack of objectivity in this case. There's that Charles Darwin quote that I have in the book about, the perfect scientist should have a heart of stone and shouldn't care which way the results go. And obviously that's not true. Obviously scientists are humans and they care. And this is just one way that manifests itself in how we do stuff.
Yeah, I tell my students that if you're going to be a good researcher, you have to let go of the outcome. Right. Which of course means that you don't invest yourself in one particular outcome or one avenue, because if you do, then there may be some inherent bias anyway in what you're looking for. Yeah. And but letting go of the outcome is quite a difficult thing to do, because very often it's your theory or your idea which is invested in this, and it's quite hard to do that. Agreed. And that, the other thing then is very often in medical fields and in medical research, it's not just your outcome. There's often the outcome of which from drug companies, big pharma, What effect does big pharma have on research from your understanding?
Well, you would expect from the kind of the way people talk about big pharma that there would be really big effects in this case, that they would be really pushing, drugs that claiming that they work when they don't. And we can all think of examples. I actually think not the most recent Alzheimer's drug, but the drug that was released before that, Aduhelm, was clearly an example of this, where there was very weak results in the paper, but the pharmaceutical company was strongly pushing for this drug to come out and marketing it and so on. But actually, in the studies I've seen, on average, the effect, yes, it is more likely that when a study is funded by pharmaceutical companies, you're more likely to find a positive result. But it's not as massive an effect as I would have expected, actually, given that kind of conflict of interest is there. And I think that's in many ways, there's various reasons for that. But I think that's because there are lots more regulations on the way that you do clinical trials. So I mentioned earlier, you have to register them, for instance. I think if you didn't have to register clinical trials, the pharmaceutical companies would get away with all sorts of stuff. They would just hide all sorts of negative data that you just never would see. So, governments have kind of got wind of that issue and have done something about it. And I personally think that, we should be registering analyses in loads of different subjects, not just clinical trials. But I also think, we shouldn't avoid mentioning the positives of big pharma. We've seen in the last few years how vaccine trials can happen, and those vaccine trials were really nice examples of clearly registered, very transparent. There were a couple of points where they changed the analysis that they'd planned, and they made that very clear. And
are we talking about COVID vaccines in particular, or all vaccines?
Yes, specifically COVID vaccines.
Yeah.
I think that's that was a stark contrast compared to some of the other stuff that you see from pharmaceutical companies, like the Alzheimer's drugs that they've been pushing recently, which really I would say are very, very weak, and in many ways might be providing false hope to patients who've been desperate, and certainly families who've been desperate for some kind of a drug for Alzheimer's, which we're really struggling to understand.
Is that because there are multiple causes for Alzheimer?
I think so, but there's also I mentioned in the book that there's a kind of an orthodoxy in Alzheimer's about the specific hypothesis, the amyloid hypothesis, that Alzheimer's is caused by these plaques, these amyloid beta plaques in the brain. That's a hypothesis that's been around for a long time. There is evidence for it. It's not like it's just a kind of a figment. But there's a study that I relay in the book about how the proponents of that tend to be quite vehement about it, and people who have come up with other hypotheses, alternative hypotheses, have felt that they were being sort of held back by what one person describes as a cabal of researchers in the amyloid field, who kind of give positive reviews to other amyloid papers and not to papers that question that hypothesis. And then more recently, there was an example of a fraudulent paper from that amyloid tradition. It turned out that it was a very specific version of the amyloid hypothesis. It doesn't mean that the whole thing is fallen apart, but just in the last few weeks, there was this announcement that someone had found a very, very dodgy set of data in an amyloid paper, and potentially because of the sort of lack of replication, that scientists are not always trying to replicate each other's work as they probably should. This had been around for 10 years or so before anyone noticed any problems.
There's you mentioned a kind of a tribalism here. I mean, when you first started, you spoke about peer review and the peer review system, which is what research seems to be founded on or helped with. And yet you've just mentioned, of course, that there's a group over here which only criticize papers which are not in their camp, and that. How strong or how weak is the peer review system, and does it work properly, do you think?
I think if you explain the peer review system to people who maybe haven't, who aren't already familiar with it, they would think, what on earth? There's so many questions that you can ask about this. So, your paper might only be seen by 2 other scientists, maybe 3 if you're lucky, before it gets approved and sent off for publication. Now, those 2 scientists are not paid for their time. They're just working researchers like you submitting the paper. They've got their own papers to submit. They've got their students to teach. They've got grants to apply for. They've got all the other stuff that academics have to do. So they have not necessarily spent a huge amount of time reviewing the paper. Now, clearly, you get good peer reviews sometimes, perhaps even often. You get long peer reviews. They give you lots of details, lots of good ideas and suggestions and corrections and whatever. We've all had experience of that, but there's nothing forcing them to do that. And we've also all had peer reviews that are 1 line, 2 lines. Yeah, this looks fine or whatever. And even if it leads to you getting a publication, you do, there's part of you that always thinks, now I feel a bit nervous that the peer reviewer clearly didn't look at this in particular detail and hasn't had much to say. And maybe I should have, maybe my paper should have been through a little bit more of a check, or at least, the more honest among us would think that. So, and then that's one thing. Then there's another problem, which is the peer reviewers, certainly up till recently, and I've seen a little bit of a move in this recently, but certainly up till recently, were never given the raw data that the paper was based on. So they were given the paper, and you could see the tables and all the summary data that the scientists have added to the paper, and they've made those summaries and so on. But you never get access to the raw data. And there are many cases of research fraud where I feel like if the peer reviewers had looked at the raw data, having access to it and then actually looking at it and combing through it are very different things, of course. One has to spend a lot more time digging into the data to really notice these kind of issues. I feel like if that, there would be a lot fewer fraudulent papers that got through that peer review filter. So the peer review system is a very strange system, and I don't think it's kind of fit for purpose. I don't really know what the answer is for what we should be doing, other than making everything as available as possible, sharing data and so on, so that there can be a post-publication peer review process as well as the pre-publication one. People can come in and read the paper afterwards and tear it apart, like all scientific papers should be.
Yeah. But is there a problem with the kind of old boys club which you were mentioning, that, you're an amyloid man, I'm not an amyloid man, and therefore I'm not going to review your paper because you're not part of our club? Is that a real problem or not a real problem?
I think that's a real problem in many fields. So I think the errors so you can see that, for instance, errors that scientists make tend to be in the direction that that would support their hypothesis, right? So when you're doing your statistics, it tends to be that your errors, you're more likely to just not check when the result is positive and so on. And I think something similar is happening in peer review, which is, I think peer reviewers will be much more harsh to. I think there's some evidence for this in kind of mock peer review experiments that have been done. Peer reviewers are much more harsh about a study that goes against their favorite theory than one that is for it. Again, that's just a classic, just a human failing. We look for errors in our opponent's position and not so much in ours. It's a very, very common thing. But there are big kind of splits and as you say, kind of old boys clubs and so on in many different fields, in many different areas. You can think of the arguments over string theory in physics. There are kind of people who are very hardcore pro and people hardcore against, and they kind of constantly battle with each other, right? Even up to, hard sciences like that, where you'd think, well, we can just empirically test and find out the answer. Well, it's not as complicated. It's not as simple as that. No. And certainly in psychology, the classic thing in my own field in psychology for through the 20th century was the people who thought there were 3 personality factors versus the people who thought there were 5 personality factors versus people who think there were 6. Tendencies of people's personality. I'm thinking of things like extroversion, agreeableness, neuroticism.
The big 5. I've heard of the big 5. Yeah,
there's the big 5. Well, before that there was the big 3, and then there's actually 6 people talk about now, and people get very entrenched.
Before that, there was the ego, the id, and the superego.
Well, exactly. So and that's a very good point, because there are still Freudians who are very entrenched in that world and write papers from the Freudian perspective.
Okay. In your book, you have a chapter which is entitled "The Replication Crisis," and you've briefly hinted that there's maybe a problem with scientists repeating the other people's experiments. Can you tell us something about that? Why is there a crisis here? What kind of crisis are we talking about?
Well, this terminology started being used about 10 years ago. It's when I was doing my PhD. I kind of got on board with this because I tried to run a replication study where I tried to do the same study as one that had been published in a psychology journal, failed to get the same results. And then there was a whole fiasco where we sent it to the journal that had originally published the first paper, and they said, well, we're not interested in replications at all. And it really impressed upon me that the incentives for scientists to check on other people's work, and indeed to check on their own work, by just simply running the same experiment again and seeing if they get the same results, are very, very poor. We're much more incentivized to move on to the next exciting thing, to move on to the next discovery, the next theory, the next whatever it is that you might be interested in testing. There's been survey studies done, and some tiny proportion of research, depending on the field, less than 1% in many cases, are of papers published are replication studies where someone is just purely just to check, running the same study again that's already been done. So my impression has been borne out in the data, but and this is a big problem, because if we keep moving on and trying to do groundbreaking research everywhere, we don't ever step back and just solidify the evidence for some hypothesis and just check if it's correct. And as we've previously talked about, if scientists are doing things like publication bias and p-hacking and all the stuff that we've talked about, each individual study becomes less and less reliable. Maybe this study is p-hacked. Maybe this study is unrepresentative of all the studies that have been done, because the ones that got null results are not published. So the studies that we see are not necessarily reliable, and it would be really nice if someone else could come along and just run that study again as closely as possible. Now, this has caused lots and lots of consternation in psychology, because first of all, what counts as a successful replication? Is it a statistically significant result? Is it a result in the same direction? Is it a result with the same effect size? And there's all these questions that you have to ask, like, from a more philosophical perspective of what actually is a replication. There's some interesting papers on what counts as replication. And then there have been these big attempts in psychology, economics, and some other fields, neuroscience, and a few others, to go back and find, take a sample of papers from, prominent journals in the literature, and just run those studies again and see if you can find the same result. And sometimes you bring the previous authors with you, and sometimes you're, trying to get the right information from them. It's very common, for instance, and this was found in a cancer research replication project. It's very common to find that the original studies don't provide enough information, a good enough description of the study for anyone to come along and replicate it, which is quite scary, given that you would expect the whole point. What is the point of writing a scientific paper if it doesn't actually communicate what you did in such a way that someone else can come along and do it? I remember being told as an undergrad that the reason you write a method section is so someone else can come along and do the exact same experiment you did, and that's clearly not the case for loads of papers that end up published in journals. So and that comes, and the reason for that, I think, is this general lack of incentive for replication. If no one is ever actually going to come along and do your study again, why bother giving a full description of the details? No one's going to pay any attention. So when people did try and do this in psychology and economics and those other subjects, they tend to find quite a low rate of replication, or certainly lower than we would want. So maybe 50% of papers, they find a statistically significant result in the same direction as the original paper. And, the effect sizes are often much, much smaller in the replications than in the original papers too. And the reason for that might be p-hacking, publication bias, the stuff that we've talked about before, which kind of distorts the original literature and makes it seem like we've got all these massive effects that are all very statistically significant and so on. And actually, that was, never the case, or maybe the effects are there, but they're actually much smaller because they've been manipulated in some way, or the more positive ones are just the ones that we see because of publication bias.
But isn't that a huge flaw in the scientific method? If say only 50% of papers, or in some cases maybe fewer than 50% of papers, are replicable, Doesn't that, I mean, knowledge has to be something which is transferable from one person to another. It has to be independent and reliable. And if you can't reproduce it, surely there's something significantly wrong here.
I agree. I think it's one of the kind of the cliched phrase that you hear often in the replication crisis is that it's the cornerstone of science is replication. Is someone else being able to come along and find the same result, and that's right. If other people couldn't replicate your experiment, then you have to ask serious questions about what happened. Was it something about the context specificity of your experiment? You did it in the US versus I did it in the UK, and maybe that's the difference. And so if that's the case, maybe if it's a psychology experiment of some kind, does that mean that there are cultural differences or something that mean that I can't replicate your result? And does that mean we've actually discovered anything universal about humans at all? If I can't find
that may be specific, of course, to psychology, but of course it shouldn't apply to physics or
quite exactly.
But even in some of the most fundamental papers, we're not talking about peripheral papers here, but even in some of the fundamental papers, there's a difficulty in replication. I think, if I remember correctly, and you can correct me if I'm wrong, but I remember one of the most famous psychological experiments, the Stanford prison experiment. I think people have tried to reproduce that and found that's not replicable either. Is that right?
Yeah, I mean, the Stanford prison experiment, you can ask whether it was even an experiment in the first place, and I wonder, if it might be better described as the Stanford prison staged occurrence or something. If you dig into that, and that's when people think about psychology, that's one of the main things they think of. That's a majorly important part of the history of psychology in the 20th century. Was this experiment that Philip Zimbardo did in the 1970s. And the idea was that if you give people the role of prisoners versus the role of prison guards, the prisoners will take on this kind of role of being the oppressed people, and they'll kind of start to have terrible anxiety and so on, and the guards will take on this role of being the oppressors, and they'll start acting violently and so on, just merely by being given the role. That was the idea, that giving people social roles has a major effect on their psychology. If you look into the details of how that experiment was done, Zimbardo, the guy who ran the experiment, was sitting there telling the guards, it would be a good idea if you deprive the prisoners of being able to go to the toilet, or things like that. Like, he was giving them all these different ideas, and plenty of other issues. There are plenty of other issues with that experiment too. But yeah, that and several other really important papers from psychology's past, including on really concepts that we talk about all the time, like cognitive dissonance, for instance. If you look at the original research on that, the numbers look decidedly dodgy. And then there was a big fad in the kind of 90s and early 2000s for this kind of priming research, where people would get primed with some kind of an idea, like the idea in one paper, they were primed with the idea of old age, and then it made them walk more slowly out of the room, apparently. And there was this whole idea that you prime people with ideas and then it affects the way they act in really strong ways.
But that wasn't replicable either, was it?
Say again?
That wasn't replicable either.
No, indeed. There was a famous non-replication of that. That was one of the kind of sparks of the replication crisis in 2012-ish. And that whole field then kind of fell apart. But the problem is, like the Stanford prison experiment, that stuff is everywhere. Daniel Kahneman's book, Thinking Fast and Slow, which, everyone has read. It's, it was a massive bestseller. It's still, you go to bookshops, you still see it in the front of the shop.
I've got a copy.
Yeah. Right, yeah. And it's a great book in many ways. It describes some really important research. Kahneman's research, his own research that he did with Amos Tversky has held up very well. But he talks about other research and is very, very uncritical of other research, which has absolutely not held up well. And certainly, and actually, if even at the time he could have looked at it and gone, well, actually, this doesn't look like a very strong study. But he didn't, because I just think there was this uncritical attitude, when talking about psychology research.
Has the Milgram experiment, the one that deference to authority, has that stood the test of time, or is that? I
actually think, unusually, Milgram himself did lots of replications of that. So I think he managed to collect something like I could be wrong about the exact numbers, but something like 1,000 participants over all the different iterations of the experiment. And he did change it in various ways. He changed the script that the experimenters were using and blah, blah. I think you do get the same result in lots of those studies, but it's the interpretation that's up for debate. So is it really the case that people are obedient to authority, or are they strong believers in the scientific method? That's one debate that's been had. Maybe they just really think that it's really important for science that they do it, and it's not that any authority would have made them do it. And another big question is, do they really believe that they're genuinely shocking someone with the electric shock, or do they think that it's an actor and they just think, oh, this is just an experiment and I'll play along? So it's not so much that you don't get the same results elsewhere, it's that the interpretation of those results is at issue.
I think there was a paper, is it by Johannes, someone who wrote the title of the paper being that most of the scientific research is wrong.
Yes, Ioannidis, Johnny Ioannidis, wrote that paper in 2005. And why most published research findings are false is the
Is that something you would agree with? Has that been demonstrated? Because it's quite significant, isn't it?
Yeah, indeed. He comes up with several reasons. He says, if we expect that scientists have this incentive and they're able to fiddle with the data and they do this, and he comes up with kind of a mathematical model of how science is published. He says, if these are all correct, then we shouldn't be surprised that the majority of findings published in the literature are false. Now, and by a certain definition of false, does he mean unreplicable, flukes, whatever? People have argued about exactly what that means, and I don't think you need to necessarily believe that is true. It could be. It's quite hard to pin it down exactly what it would mean, but you don't need to believe that. Even if a huge chunk of research findings are false, it's still very scary. It doesn't necessarily need to be 51% or more. But that's a paper which is well worth reading, because it shows that there are all these different biases that can come in at all different stages of the research process. And even if you don't believe his mathematical model, and maybe you even think that it might be a bit of an oversimplified mathematical model, because of course the actual reasons people publish stuff and the reasons they make decisions on their scientific papers are very, very complex and can't really be summed up in a simple little model like that. Even if you believe that that's oversimplified, it's still well worth reading. And it's been many people's introduction into the whole replication crisis thing. And in fact, it was very ahead of its time. As I say, it was published in 2005. Nobody really, it created a bit of a fuss at the time, but nobody started making the changes and trying to do replications and all the sort of stuff that happened, kind of 5, 6, 7 years after that paper was published, when the kind of real replication crisis discussion began.
Right. You also have chapters in your book on both bias and even fraud. Is fraud common amongst papers? I would have assumed that it's very, very rare.
If you ask scientists if they've ever committed fraud, so there's a meta-analysis of surveys that have been done. If you just ask scientists, have you ever committed fraud, defined as fabricating data entirely or falsifying a genuine data set, so changing some of the numbers.
Again, there must be a spectrum of that, because you find that you've got a set of points on a graph, and one of them is outlying somewhere and throwing your results out, and you think, I'll just ignore that one. Yeah. Is that fraud, or is that? Well,
exactly. I think there's a huge gray area, exactly as you say. But if you just ask people if they've ever done anything like that, they say 2% of people say yes, I've done that. 1.97, I think, or something like that. So almost 2%. And then if you ask people, do you know anyone who's committed fraud, your colleague, someone that you've worked with who's committed fraud, I think 14% say yes. So in that survey. So I suspect the first number is much lower than the reality. I don't know how to really think about that second number. You might think that people are, if they're thinking of their rivals, oh yeah, he probably does commit fraud, and that might be a bit biased in that respect. But it's clearly a minority, but I think it's a lot more common than we would like to believe. And that's not just on the basis of that survey. I think, the fraud cases that we see, and every so often there's a scandal about scientific fraud. I mentioned the Alzheimer's paper before, the amyloid paper. Every time there's a scandal, I just think, how many fraudsters are out there with false data who have not been caught yet, who have not been not had their fraud discovered by by some data sleuth who's gone and dug into the raw data, or noticed patterns that don't quite work in the summary paper itself.
Yeah. I would have thought that hopefully fraud is low-level stuff, but maybe much more common is, and you have a chapter on this too, bias, because there can be kind of implicit biases, or biases which usually that you're not aware of when you're manipulating your data or taking your samples or whatever it may be. Are there any particular biases which you would single out as being maybe the most common that people fall into?
Yeah, well, we've already talked about the bias towards positive results. I think that's a massive thing, and that's that kind of publication bias. But there are other biases that affect not just what you choose to publish, but how you do the analysis. A lot of these are things which you can tell yourself are actually completely fine to do, but some of them, as we've discussed, kind of blur into fraud. So I mentioned, for instance, the story of Brian Wansink, who is this food psychology researcher at Cornell University, so top university, big deal name, who was writing in his emails to his students, there must be something we can do to get that p-value below 0.05. We've got to find something in this data. We've gone out and collected the data, so there must be something. And I think that bias towards not even necessarily finding positive results, but just finding something, just finding, not necessarily the thing that you planned, but just digging through the data and just finding anything. The bias towards making something publishable, as you imagine publishable to be, is clearly there. And that was a rare example where we actually have an email of him writing that to people. But this must happen all the time. People must, bosses of labs, professors, and so on, just putting slight pressure on their PhD students, postdoctoral researchers, and so on, to get the results that they feel like they want. And it's all part of this p-hacking thing, is you end up leaning on certain results. And then there's another kind of bias, of course, which is political bias, which is there are certain types of findings that people find more acceptable to their political side than others. And what you always end up upsetting people when you talk about this, because you upset one or two people on the other side of the political spectrum. But for instance, I talk about in the book, the example I give is of stereotype threat. I hate to give so many examples from psychology, but this is just my my field. Stereotype threat is this idea that if you, in this particular case, if you tell girls in school that boys are better at maths, then it will depress the girls' scores. They'll get lower scores because they feel threatened by the stereotype that girls aren't as good as boys are at maths. So that's the idea. And that's been spread very far and wide. People in schools often hear about this. Teachers are told about this on teacher training courses and so on. And then a few years ago, someone came along and did a meta-analysis of all the literature on the topic. And they were kind of quite skeptical scientists. And in fact, they've not just done a meta-analysis, but they've done their own replication studies too. And they found out that, the idea of stereotype threat actually, it turned out that there were lots of studies missing that should have been there if the data were, even if the effect is real, you'd expect there to be a few null studies published there. Yeah. And there weren't as many as people expected, as would be expected, mathematically. And one explanation for that, I don't think it's the only explanation, but one explanation for that is that it's just much more politically acceptable to say, well, look, there's a huge problem with gender bias in maths, and we need to fix this. And it's all from a good, well-meaning perspective. We want to improve girls' scores at maths, and we think this kind of sexist idea that boys are better and so on might affect them. And I think people are less critical of the research because of that reason. And I also think they're more likely to publish research that supports that side than says, actually, there's no stereotype threat. Actually, girls are doing fine regardless of what you tell them about boys. But that was a big debate in psychology for a long time. And I really think that has all fallen apart. But I think it's the reason people are so into it is because of a political bias.
Yes, and that governs the whole part of things. So, I mean, well, basically, you were saying that some of the data may have got missed out because it didn't support the political goal, possibly.
One explanation, yeah. I also, there's other reasons to suspect political bias as well in some areas of science. Obviously, you can't get inside someone's head and know exactly what was pushing them in one direction or another, whether it was just desire for a positive result or desire for a positive result that supported their political position or whatever. I mean, there was also a big scandal during COVID in some very top medical journals, the Lancet, the New England Journal of Medicine, about hydroxychloroquine for COVID. So there were some, I would say, very dodgy studies that came out originally that said that it worked, that hydroxychloroquine made people less likely to die from COVID. Then in about May of 2020, there were two big studies in those top journals, Lancet, New England Journal of Medicine, which claimed that hydroxychloroquine was actually bad, that it actually causes people to die more often than a placebo. It wasn't a placebo-controlled trial. It was an observational trial. So just die more often than people who weren't getting hydroxychloroquine. And these papers had to be retracted within 2 weeks. It turned out that someone at this company called Surgisphere had given a very dodgy data set. I don't think it's been officially called fraud yet, but it certainly looks that way. Had given that to some Harvard researchers, and they just published it without looking at it, without checking the data at all. And you've got to ask, what was it that made them not want to check those data? Now, one reason is there's an emergency. We need to get these results out there. It's a pandemic, all that sort of stuff. But I suspect another reason is that Donald Trump had just been on the TV saying hydroxychloroquine's great. I think he called it a game changer. And I suspect a little part of them might have wanted to just, be able to say, our results show it's not just that Donald Trump is promoting an unproven remedy, but he's actually promoting a dangerous one that makes people die more often. And I do think that sort of bias can lead people to, be less skeptical than they should of dodgy looking scientific results.
I agree. I mean, I think that if you view research dispassionately, then it has to be a single-minded pursuit of the truth, regardless of where it leads you. But very often people might substitute something instead of the truth for it, and for the best of motives. They have an ethical concern, for example, and they want to push society in a particular way because they think it's much better for society, or better for individuals, or better for human beings as a whole, or society as a whole, and therefore the research is skewed. But once you've moved away from the truth, you actually may not be producing the best result at all. In fact, I would argue the case that if you ever move away from the truth, you're not going to get the best result, no matter how good the intentions might be.
Agreed. And I think there's examples that this might be becoming a problem in science. I saw the editorial in Nature Human Behavior, which is a journal, a kind of psychology journal published by the Nature stable of journals, which argued that, which made the case that the editors will be retracting or correcting research if it may potentially offend a particular group of people. Now, that's what they said in the paper, and that's going to be their policy in future. And I do worry that might mean that any interest group, regardless of what side they might be on politically, or what where they might be, whether it's a advocacy group for one cause or another, it's possible that they would be able to interfere with the scientific process of papers which are perfectly valid, experimentally and scientifically, but that might have results that upset one group or another, a pro-life group, a pro-choice group, whatever it happens to be, and I worry that now that's been written down, that these groups will try to, push editorial decisions.
Blatant interference in the scientific process, it seems to me, because you're definitely biasing the outcome according to your own personal political views. And there are many cases like that. I mean, the most controversial one, I suppose, of all is Charles Murray, who's come up with all kinds of debatable results on his research. But the thing which I think the important point is, whether you agree with Charles Murray or not, there's no platform for any debate to be taken place anywhere to discuss his results, because it's just taboo. and therefore you can't even debate the issue. And that
There's
means
a
you're never going to get it.
there's a sort of unfortunate dynamic in that sort of research there, where the only people who comment on it are people at the who are at the very extremes, because people who are in the kind of middle of the road don't want to go anywhere near it, because, as you say, there's this taboo about it. People don't want to talk about these kind of things. This is, for anyone who doesn't know the context, the idea that there are differences in IQ scores between groups of people.
Between different races, that's what
races, and but also sex differences as well are another controversial thing. Just group differences in general. I would much prefer to live in a world where we debated these things and really tore them apart in a very open way, than one where anyone talking about this issue is either someone who is a strong believer that there are differences, or someone who is a strong denier that IQ has any use whatsoever under any circumstances.
It's left to the extremists, as you said, rather than to sensible debate. Well, we're coming to the end, and thank you for your time, Stuart. Well, one last question, which takes us really to the end of your book, because we've pointed out many of the flaws with science, flaws with peer review and biases and even fraud in different cases. You've got a chapter which says, how do we fix science? So how do we fix it and make it work better?
Well, I don't have, I don't know what the answer is, or the set of answers is. I think we need to trial lots of different ideas. We are scientists after all, so we should be going out there and trying one idea and another, and evaluating using meta science. And a lot of the stuff I'm talking about in the book is meta science, the science of science. Even talking about the percentage of results that are published that are positive is a meta scientific question. So we need much more of that meta science to research this. But here are a few of the ideas. So the one idea which I really strongly support is this idea of they're called registered reports. So I mentioned earlier that clinical trials need to be registered in a government registry before you do them. One kind of more even harder version of that is a registered report, where you don't just put your plan online for what you're going to do in your study, but you actually submit your plan to peer review. So the journal says, we will accept, you just sending in your introduction and your method section, basically, so that, your intro to the general area, and then here's what we are going to do. They send that off for peer review. The reviewers can say, well, I wouldn't do it that way, or perhaps you maybe want to consider this statistical test rather than the one you've done, or maybe you want to increase the sample size quite dramatically here because you haven't got enough people. Whatever it is, they can do the full peer review of the design of the study. And then the really crucial part is the journal agrees to publish your results, whether they come out positive, negative, ambiguous, if you do what the reviewers have asked you to do, right? So if you do what you say you will do at the end of the peer review process, and then you go off and you actually do the study, you collect the data, you run the analysis, you write it up, you send it back into the journal, the reviewers look at it again and say, oh, yeah, they've done what they said they would do, and then it gets published. And, that, as I say in the book, kills publication bias stone dead, because you've already given people the incentive. As long as you do what you said you would do, we'll publish your paper. You'll get a publication out of it. And it's all about. Sorry, say again.
I was going to say it also assists with letting go of the outcome, because if you know you're going to get published regardless of whether it's positive, negative, or undecided, then
you may as well just do the analysis you said you'd do.
Just follow the truth.
So, fundamentally, it's about making the decision to publish a paper based on its method, based on the quality of the design of the study. At the moment, you're making the decision to publish the paper based on the results of the study, or certainly something that, related to the results of the study. It might be a combination of the method and the results, but a lot of the decision is being made based on the results. So that's one thing. I think that's a genius idea, just a very simple way. And there are now a lot of journals that offer that. It's still a minority of papers that get published in the journals, but there are a lot of journals that offer that registered report format for publishing papers. So I think changing the way we publish papers is one thing. I think we could also do things like changing the way we do peer review. I talked about making sure that data are open for anyone to look at, including the peer reviewers of a paper. I also think journals can do easy things like scanning every paper that comes in. There are a few algorithms now that can check for statistical errors, and even in some cases check for fraud in some simple cases. I mean, it's kind of a moving target, because as soon as you start checking for one type of data manipulation, the fraudsters will start doing something else, if they're clever enough.
But AI can pick up on certain patterns which should be there, even slightly anomalous patterns which you'd expect in standard data, and
and not in fraudulent. Yeah, exactly. And so those kind of things I think could be done much more often. And I think that that idea of publishing your data online leads to this whole broader idea of open science, which is that we need to change the culture of science, and this is much easier said than done, away from one where the science is done kind of behind closed doors in this kind of ivory tower situation where no one ever sees it, and instead is made available to everyone. So the data are published online, the methods of the study are published in as much detail as possible, and even resources are shared. Maybe you've used some particular computer program or whatever. The statistical code of your study is shared online, and the journal is made open to the public to read, so anyone can read it, and we can engage in this process of post-publication peer review. The idea that just because a paper is published doesn't mean that it's set in stone. It's not etched into a tablet at that point. It's still available to be critiqued and so on. And we need to get much more into that kind of way of thinking. So that move towards open science is a big deal. And I see some universities being interested in that, and being interested in changing the way we hire scientists and promote scientists and reward scientists, not just on the basis of just how many papers they've published, but on the basis of what a contribution they've made to the scientific community. And that could be, designing new ways to help people share their data online, or something along those lines. It could be running replication studies. It could be helping people collaborate with each other. Whatever it is, these are changes that we can make at the kind of a cultural level of science. So there's specific things that we can do about the analyses that we do, about the publication, and then about the wider culture. And I think these are all changes that need to be made. Another, so those are journals and universities. I also think funders are a big part of this too. Scientific funders could simply demand that in order to get your money, you need to make sure that all the data are published online when you finish the experiment. You need to make sure that you publish them in a registered report format, so that the decision is not, the decision to publish is not made on the basis of the results. So there are lots of different people that can change: the scientists themselves, the journals, the universities, the funders. I talk in the book about bottom up and top down ways of changing culture, and none of it's easy. But I think over the past 10 years, we've seen a lot of positive changes. Journals saying that they will accept replications, journals running open special issues about replication debates and all that kind of stuff. So I think these are all very positive, and generally the conversation about open science is much bigger now. But it is still a small core of researchers who are interested in this, and we need to try and get the word out. And this is one of the reasons I wrote the book, is to try and get the word out further to people, to say we've got a lot of problems, and it's not just going to take, there it is. We're not just going to take, a small number of changes. We really need to make big fundamental change to the way we do science in order for it to become as reliable as we need it to be.
What kind of reception have you had? Because it's quite a controversial, I would say, book, because it points out many of the errors which possibly people might not want to be pointed out. Yeah. What kind of response have you had to it?
Well, on the positive side, people have been very, very kind. I've had emails from all sorts of people at all different levels of science, PhD students saying, I found this really inspiring to make sure that my science is reliable, and I love that. I've also had, a chemistry professor from, I can't remember which one of the University of California universities got in touch to say, look, I agree with you, but you can't say this stuff in public because it will mean that people start to distrust science. And I thought, what better reason to distrust science would there be than finding out that scientists are deliberately, holding back the truth. That's exactly the opposite of what we want.
Exactly.
So, that's been, some of the reception I've had of scientists who, are aware of it. And then, I haven't had that much denial that there is a problem, right? So maybe one review that I can think of that said, these problems are over. Scientists already know about this stuff. These are all being dealt with. And I just think that the pandemic, for instance, the science in the pandemic showed that was completely wrong. That all the problems that I talked about in the book were reproduced at some point in the pandemic, in some of the science that we came across. So generally I would say vast majority positive, but the odd, strange reply from people who maybe just don't want this stuff to be talked about in public.
Maybe not. It's an excellent book though, and it's one which I recommend to my own students. Science Fictions, Exposing Fraud, Bias, Negligence and Hype in Science. One last quote from the back, because we've said some quite critical things about science, but it says, Matt Ridley adds at the end here, scientific knowledge is the greatest human achievement bar none. That has been achieved despite the cock-ups and the crimes and the confusions that bedevil the scientific process is almost miraculous. But Stuart Richie tells gripping tales of increasing recent villainy and bias in the laboratory, which should worry those of us who love science, and also some positive things about how to keep it on the right track. Thank you for that, Richie. Can you do you have any other books? Do any other projects on the go, Stuart?
Yeah, my next step is to. A lot of people have asked me, when I've done talks and stuff in the Q&A session, they ask me things like, "Well, okay, I'm not a scientist. I'm not an expert in this area. So how do I make my mind up if we can't necessarily trust the research?" And I do have a little appendix in the book about 10 things you should think about when you're reading a scientific paper. Yep. But basically the next book, I think, and I'm just trying to work out exactly how I'll pitch it and how it will look, the next book will be an expansion of that appendix, basically, is how to read a scientific paper and generally how to assess claims that you're not an expert in, and the sorts of things you should be thinking of, and the sorts of biases that might affect the people who are claiming to be experts in the field. So I think the next one is kind of almost like a popular epistemology book or something to try and help people make their minds up on controversial topics.
Well, I think that would be very useful, actually, because I point my students to that appendix when I get them to review scientific papers. That's a guide for them. Stuart Richie, thank you ever so much for your time and for an excellent conversation today on science fiction. Thank you.
Thank you.